Hello and welcome to Otten Math. In this edition of Otten Math, we're going to talk about applying properties and properties of logs. All right, so this is actually part of your homework from last night, or similar from the homework from chapter 5.5 where we started talking about logs. And so what's given is that log with a base of 10, so just a common log, 6.92 is equal to 0.84. And now you're supposed to figure out, without using the properties of logs yet, how to convert or use what you know about the value of log of 6.92 equal to 0.84 and tell me what, or tell us what log of 692 is, log of 0.692 and log of 0.00692. So I'm going to pause here while you think about it, come back in a moment and we'll talk about the answer. Right, so I've gone through the solutions for the problem. So essentially what you want to do is you want to convert the log to exponential form. And then think about how you can use the value in exponential form to supply the answer that's required. So log 6.92 is equal to 0.84. I can rewrite as 10 to the 0.84 is equal to 6.92. Well, ultimately I'm looking for a log of 692. So how can I rewrite 692, or 6.92 is 692? And the answer is, well, if I multiply 6.92 by 100, then it'll be equal to 692. So what I want to do is I want to multiply both sides by 100, and I get 10 to the power of 0.84 times 10 squared is equal to 692. And then I can use the properties of exponents. So when I multiply with the same base, I'm going to add the exponents. So 692 is equal to 2.84. Now I can use what I know about this value, 10 to the 2.84 is equal to 692, and rewrite it as a log. So I can rewrite it from exponential form to log form. Log 692 is equal to 2.84. So that's how you handle these types of problems. So what it's telling you is ultimately, and we're going to show this later with a product property of logs, is that when you have two logs with the same base and you add them together, you're actually multiplying the values that are part of the log. And so we'll show this again when we go through the properties of logs in about 5 minutes. Okay, so I've given you the answers for the other two problems. You can check your work. And let's go on and let's take a look at another set of problems now dealing with natural log. I'm going to pause here while you work out the answer. All right, so in this case, it's a little bit more tricky because we're dealing with negative exponents. So in the first case, natural log of 0.82 in relation to 5, natural log of 5 is equal to 1.61. I know the natural log of natural log of 5 is equal to 1.61. So I can write it here and then rewrite it in log form, and then think about what the value of 5 is in relation to 0.2. So 5 to the negative 1 is equal to 1/5, which is equal to 0.2. So if I take e to the 1.61, which is which is natural log of which is equal to 5, and then I apply a negative exponent to it, I have e to the 1.61, which is equal to 5, and I take that to the power of negative 1, and I end up with e to the negative 1.61. Right. Similarly, I have e to the 1.61 is equal to 5. I know that 5 squared is equal to 25. So if these two values are the same, I can take e to the 1.61, the second power, so power of the powers, and end up with e to the power of 3.22 equal to natural log of 25. Similarly, e to the 1.61 is equal to 5. 5 to the negative 2 is equal to 1 over 25, which is equal to 0.04. I can then express e to the 1.61, again, which is 5 to the negative 2, and that leaves me with e to the negative 3.22. Right, so that's how you solve these problems. Let's move on and talk about properties of logs. So remember, there are three properties of logs, and you can they work in both directions, meaning you can expand the value and you can condense the value. And we're going to talk about what it means to expand and condense for each of the properties. So the product property says if I have log base b of m times n, some product, I can break it into its factors, m and n, by separating the logs with a plus sign. So product property says log base b of some product is equal to log base b of a factor plus log base b of another factor. And so if we go back to the original problem here, we see that what's really happening at the level of addition is we're multiplying the values together, but we're adding the exponents. And so that's what they're getting at in this problem here as they elaborate the product property. So the product property is just the addition of the exponents in the exponential form, but then converted to the log form. So product property says that we add these two values, which are the factors of the product of that given log. So the quotient property, and by the way, this is expanding the log. Condensing the log would be taking the factors and then combining them into a product. And of course, you have to recall that the base has to be the same between the two logs in order for you to transact that property in the condensed fashion. Quotient property says you can take the quotient and separate it into dividend and divisor. So log base 3 of 51 over 7 is the same as log base 3 of 51 minus log base 3 of 7. Power property says log base 3 of 51 squared is the same as 2 times the entire quantity of log base 3 of 51. And again, this goes in both directions. So when I am condensing the quotient property, I can take the dividend and divisor and then rewrite it as a quotient. Again, the base has to be the same. And then condensing 2 log base 3 of 51, I can reapply the value of 2 as that coefficient in front of the quantity log base 3 of 51 as the exponent to the value of 51. All right, so let's take care of some problems as classwork. I'm going to give you an example here. Log base 5 using the product property, and we're going to go through each of the properties. Log base 5 of 625 is equal to the same as, now we're using the product property, log base 5 of 125 plus log base 5 of 5, which is the same as 3 plus 1, which is the same as 4. I want you to evaluate log base 3 of 72. I'll pause here. All right, log base 3 of 72, I can separate it into its factors. And if I can find a factor that allows me to simplify the log as an integer, then I want you to go ahead and simplify it that way. So log base 3 of 8 plus log base 3 of 9, which leaves me with log base 3 of 8 plus 2. All right, second property, quotient property, log base 36 of 16 is equal to log base 36 of 1 minus log base 36 of 6. Log base 36 of 1 is equal to 0. Log base 36 of 6 is equal to negative 1/2. 0 minus 1/2 is negative 1/2. You can evaluate this example on the bottom in blue. I'll come back in a moment. Log base 6 of 5 over 36 using the quotient property is log base 6 of 5 minus log base 6 of 36. Log base 6 of 36 is 2. So we end up with log base 6 of 5 minus 2. All right, last one, power property, log base 4 of 49 is the same as log base 4 7 squared, which is the same as 2 log base 4 of 7. I have a couple examples here I want you to work through. I'll pause for a moment, and then we'll come back and check your work. All right, log base 8 of 4 is the same as log base 8 of 2 squared. 2 log base 8 of 2, which you can rewrite as 1/3, and then 2 times 1/3 is 2/3. Second example, log base 7 of 81, you can rewrite as log base 7 of 9 squared, or more effectively and efficiently, log base 7 of 3 to the power of 4, which leaves us with 4 log base 7 of 3. And ultimately, if you can simplify or rewrite the values such that this value here is the smallest, and I can bring that exponent out in front, then that's what I want you to do. So 4 log base 7 of 3 is the answer that I'm looking for. All right, so we're talking about expanding and condensing again. Expanding means to separate the values from the product to its factors, from the quotient to dividend and divisor. Condensing means to combine the values. And in the power property, expanding means to take the power and apply it to the front, and condensing means to reapply it to the power of this value. All right, so let's expand some expressions. I give you a couple examples here. Log base 3 of 4x is equal to log base 3 of 4 plus log base 3 of x. Natural log of 12 over 5 is equal to natural log of 12 minus natural log of 5. And I want you to evaluate the two expressions on the bottom. I'll pause here and come back. All right, so on the bottom, log base 10, or the common log of 3x to the fourth, is the same as log 3 plus 4 log x. So be careful. This would supply a different result, right? And then I'd have to apply the exponent to both logs. But because it's only attached, so to speak, to the 4, then the 4 exponent only applies to the x. Number 2, log base 4 of x over 3y is the same as log base 4 of x minus, in parentheses, log base 4 of 3 plus log base 4 of y. Okay, moving on. I want you to expand the expression. I'm going to come back and show you the answer. Here's the answer. I think pretty straightforward. Again, if you condense, you have to make sure all the bases are the same. Okay, condensing expressions. Here are some examples. Log base 4 of 7 minus log base 4 of 10 is equal to log base 4 of 7 over 10. And so I want you to notice that I've written the plus and minus here because the location, first, second, of these two logs is really not important. What's important is the sign in front of them. So I could move negative log base 4 of 10 to the first term and positive log base 4 of 7 the second term, and I would still have the same log expression. So the minus sign just means place it in the denominator, and the positive just means place it in the numerator. So be careful because the book will give you values or signs in, let's say, out of order to what you're normally seeing, the plus first and then the minus second. All right, so second example, 2 log base 10 of x plus log 11, the same as log of 11x squared. So I want you to take care of the second two problems. All right, and we see natural log of 12 minus natural log of 4 is the same as natural log of 12 over 4. And one other thing I want to point out is this is not the same as natural log of 12 over 4. So please be careful when you're writing these values. The log goes outside the 12 and 4, remain as the separated quotient. All right, 5 log x minus 4 log y, log of x to the 5th minus y to the 4th. All right, so I want you to condense this expression. I'm going to pause here and then come back. So you get log base 3 of 20 over 4 squared plus log base 3 of 4 to the 1/2. Log base 3 of 5 squared is 25 plus log base 3 of 2. And now I'm going to use a product property, condensing the expression log base 3 of 50, which is your final answer. All right, solving log equations, we're going to go through this quickly. There are really two strategies we're going to use: equating logs and exponentiating logs. Equating logs, properties of equality. If I have log base b of x equal to log base b of y, I can say that x is equal to y when b is greater than 0 and b can't be equal to 1. All right, so property of equality, log base 7 of 49 is equal to log base 7 of x. X is equal to 49. I'm going to give you a couple of problems, and we're going to come back and check your work. All right, we're running out of time here, so I'm just going to ask you to evaluate and check your work here. You can see that the problem number 3 turns into a quadratic, and you end up with 2 values. And so you have to be careful on the second value. You end up with log base 4 of negative 5, which you can't evaluate. So that value is going to be an extraneous solution. Okay, exponentiating logs. Exponentiating logs is when I have log base 7 of an example. The quantity 3x minus 2 is equal to 2. So I have log on one side is equal to some value. I can exponentiate the log equation, so it becomes 7 squared is equal to 3x minus 2, and then solve x is equal to 17. I'm going to give you some problems. You're going to solve for these. I'm going to show you the answers, and we're going to be done. All right, that's it for this edition of Math.